Good evening friends. In this segment I am going to explain you the projectile motion in the inclined plane. In last session you have seen the oblique projectile motion and its characteristic equations of motion, range, maximum height and time period. Okay, so the basics of the projectile motion in the inclined plane is this, that there is a plane which must be inclined, which must be having some particular angle with respect to horizontal line. Let's suppose here I am just considering this particular plane xy. As we know that plane is a combination of two axes. So I am just drawing, let's suppose this is our axis x and this is y. The region which comes in this particular range, that is called plane. Now this particular plane is making an angle alpha degree with respect to horizontal or with respect to the ground line. That's why it is called the angle of inclination. Okay. So as it is related to our projectile, so let's suppose with respect to this particular plane, any body is thrown vertically upward with the initial velocity u. So suppose at this particular point A, I am just throwing any body with a speed of u in a vertical manner, okay, which is making an angle theta degree with respect to this particular inclined plane. Here the point should be noted that this particular inclined plane is making an angle alpha degree with respect to the real ground axis or real horizontal axis, but the body is making an angle theta degree with respect to this inclination plane. Here our consideration for the motion will be only limited to the inclined plane. Okay. So I am just supposing this particular body is just moving upward and here this is angle theta. So one component will be in the horizontal, or you can say in this particular x-axis direction, and one component will be towards the y-axis direction. So we better know, as it is velocity, it's a vector quantity, so we can resolve its horizontal and vertical component. So if this angle is theta, then this would be u cos theta and this will be u sin theta. U cos theta assists the body to move in this particular direction, means along the x-axis direction, which I am just mentioning for this particular inclined plane, and by the help of u sin theta component it will move towards the y-axis. So these two components assist the body to move in horizontal as well as vertical direction. When we consider a u cos theta, it means we are just considering this horizontal motion, and when we are just considering this u sin theta, it means that we are just considering a motion for a vertical direction. So let's suppose the body moves in such a way, so as it is clear that it's a projectile motion, and the path is also called the trajectory of projectile. Here one thing is important, the nature of gravity. We have to understand the nature of gravity. As we know that earth attracts each and every body towards its center, means the direction of acceleration due to gravity is always perpendicular downward. What? Perpendicular downward. So we have to just see on this particular figure, this is the direction of acceleration due to gravity, this particular. Let's suppose our inclined plane is making an angle alpha degree and this angle will be always 90 as it is perpendicular downward. So with respect to ground it always makes an angle 90 degree. So what will be this particular angle? If it is alpha and it is 90, so it forms a triangle and the sum of all the angle of interior angle of the triangle is 180 degree. So from where it will be 90 minus alpha. So let's suppose this is our inclined plane, okay, and I am just making a perpendicular, okay, and this is our what? G. So if this angle is 90 minus alpha and whole angle is 90 degree, so what will this angle? This angle will be alpha. That's why I am just mentioning here what? Alpha. Now acceleration is a vector quantity, so we can just resolve its two component as we require here. So if G is in a downward direction and if this angle is alpha, so the component which is connected to alpha will be of cosine component. That's why this component will be G cos alpha, which is acting in this particular direction. Okay, So g cos alpha will act in this perpendicular direction with respect to this particular inclined plane. That's why I have written g cos alpha, that is the vertical component of the g, which is acting downward in the y axis. Okay, same we can just resolve g sin alpha. If this is the g cos alpha, okay, let's suppose this is alpha and it is g, so it will be g cos alpha, and perpendicular to it this component will be g sin alpha, which is acting in a horizontal direction. Now you have to understand two things which is important. Let's suppose in a practical condition when the body is just moving upward. So two things are there. The body is moving vertically upward and it is moving towards the right side, but our g cos alpha component is acting downward. So if I am just considering a motion in a vertical manner or in a vertical upward direction, so there will be retardation because the acceleration is acting towards downward direction. So if we are considering a vertical motion, then there is a case of retardation. I hope that you are getting this point, because the g cos alpha is acting downward but the actual motion is in vertical direction. So if g cos theta is accelerating portion downward, so we have to use minus g cos alpha for the vertical motion. Minus g cos alpha act as a retardation in a vertical direction with respect to this particular xy plane. Same, you see here, g sin alpha is acting in a left direction but the body is just moving from A to B towards right direction. In a horizontal manner it is just moving in a right direction but the actual component is acting in a left direction. So here is also a case of retardation. That is why very important thing is if I am just considering this xy plane, this particular xy plane, inclined plane, okay, and the body is just moving like this. So one component will be towards the y-axis direction and the one component will be towards the x-axis direction. So if the body is moving horizontally, if I am considering a horizontal motion, then I have to use minus g cos alpha due to the retarding factor, because g sin alpha is accelerating factor towards the left direction, but if we needed to move in a right direction, then we have to use what? Minus g cos alpha, retardation portion. Same, g cos alpha is acting in a downward direction, but if we are just moving vertically upward, then we have to use what? Minus, sorry, if I am just moving in a horizontal direction, then I have to use minus g sin alpha. In a vertical direction I have to use minus g cos alpha according to this particular diagram. I hope that this point is clear, because it is an important point and that particular acceleration or retardation we have to use throughout our motion. Now just see some important parameter. We have to check some important parameter. So I am going to calculate the time period for this inclined plane projectile motion. So let's suppose the basic formula of time period for the oblique projectile motion is what? T is equals to 2u sin theta upon g. One very important criteria is u sin theta was the vertical component, and as we know that g is itself perpendicular because the direction of g is perpendicular downward. So for this particular projectile motion which is in the inclined plane, what is the main important thing? That firstly we need to find the vertical component of the velocity, means we need to find what? Perpendicular initial velocity and perpendicular acceleration by which it is moving upward. Let's suppose from this basic formula we can just tell that we can just find the time period for any projectile motion, any kind of projectile motion, just by using this formula, that T is equals to 2u perpendicular component upon g perpendicular component. Okay, so just see here, with respect to this particular inclined plane, u sin theta component is acting upward. Means we can use what? In a place of t, I can use 2 into u sine theta. Okay. And g cos alpha component is acting perpendicular downward with respect to this particular xy plane. Means in a vertical upward direction, same component will be there but with the negative sign. But here time period, we are just finding the time period's magnitude. So simply we have to use the vertical component of this acceleration, that will be g cos alpha. So this is the formula for our time period of projectile motion in the inclined plane. This is very important, and I think that is easy also. You are getting this point all. Okay. Again, I am just performing for the maximum height component. We need to find the maximum height also for this projectile motion in this inclined plane. So just see on the board. The basic formula of the horizontal maximum height is h is equals to u square sine square theta upon 2g. This is the formula which we generally use for finding the maximum height. Now see here, this is what? This is u sine theta, means we have to use the perpendicular component of the initial velocity. Same, g is itself perpendicular component which is acting in a downward direction. So we have to use the vertical gravitational acceleration component. So for finding the maximum height, we have to use perpendicular component of the gravitational acceleration. So just see here, maximum height h max is equals to, here u sine theta represents the vertical component of the velocity for this inclined plane. So u square sine square theta will be remain same, u square sine square theta upon 2. We have to use a vertical component of acceleration. So now see here, the vertical component of the acceleration is what? G cos alpha, because it is acting perpendicular downward. So if we are just moving a perpendicular upward, so retardation will be there, but the magnitude of retardation and acceleration is same. That's why we can use G cos alpha. This is very important thing, that we are using here G cos alpha as a magnitude only, because we need to find just magnitude. Okay, and height and the particular time period are the scalar quantity. That's why I am just putting only magnitude, not with the direction. So in a place of G, I can put G cos alpha. Okay, so this is the formula for the maximum height obtained by the body which is moving in this particular inclined plane. Okay, we can just find the range also. This is very important parameter to find the range in the inclined plane. Means we need to find the distance between this point and this point. We need to just find the horizontal distance between AB. So now see here. Okay, if I am just considering, you see here, let's suppose this is our point A and this is our point B. Okay, and we need to find this particular range R. Okay, so two things are there. We have to use the simple general motion equation. So for finding a distance, I can use the second equation of motion, that is S is equals to ut plus half at square or minus half at square. According to need, we will use. So you now see here. Okay, from figure it is clear that acceleration due to gravity is g sin theta, which is acting from B to A. But in actual motion, we need to move from A to B. Means g sin theta component will be there, but it will retard the motion, not accelerating, because the acceleration direction is B to A. So in opposite direction if I am moving, so same component will be there but with the negative sign, because it acts as a retardation. If the body is moving from B to A, so this particular acceleration will be assist the body to increase its speed. But if I am moving from A to B, so this component will act as a retardation. This is very important point, and it is clear from a diagram also that if I am moving from A to B, so G sin theta component will be act in the direction AB, but as a retardating factor, not accelerating factor. So simply I am just using the formula that S is equals to ut plus half at square. Now see the modulation in this particular formula. S is a distance, so distance is range I am considering. U is the initial velocity in a direction of that particular motion. So now see here, in this particular direction, the initial component of the velocity is u cos theta. Now we need not to take this particular u, we have to take u cos theta along this particular direction. So if I am considering the horizontal motion, then simply we have to use what? Horizontal component of the velocity. That's why I am using u cos theta. So mean in a place of u, I am putting u cos theta. Okay. Now t is the time reaching from point A to B, and I think it's a time, it's a flight time, because it's a total projectile motion path time, that how much time it will take from move to A to B. So it is a total time in which the body remains in air, and that is equals to flight time. So in a place of t, I am using this capital T, that is a denotation of flight time. Now plus half a, this is the important point. If the acceleration is there, then we can use plus a, but this is a case of retardation, as I explained earlier also. The body is moving A to B, so this will act as the retarding factor, means I have to use what? Minus half, in a place of A I am using what? G sin alpha, minus half G sin alpha into time is equals to flight time, means half t square. This is the standard equation by which we can get the value of R. Now earlier you have proved the flight time formula, that u is equals to 2u sin theta upon g cos alpha. So in a place of t you can put this particular equation. So now see here that R is equals to u cos theta, in a place of t put this particular value, 2u sin theta upon g cos alpha minus 1 by 2 g sin alpha into t square, means whole square of it. So you will get 4 u square sin square theta upon g square cos square alpha. Okay, you can further solve this particular result also if you need it. So just see here that R is equals to u upon g, and sorry, u square u square upon g cos alpha. Okay, now 2 sin theta into cos theta, we can write sin 2 theta also. So we can just write in this manner that sin 2 theta minus two will cancel out, and you will get minus 2u square sin square theta into sin alpha upon cos square alpha, and this g and one component will cancel out, and in upon you will get g. Okay, so one important thing is there, if you need it, so you can take common u square upon g cos alpha, you can take common u square upon g cos alpha. So if I need it, so I can take common also this factor. Then your R is equals to u square upon g cos alpha. If you can take common, then you will get sin 2 theta minus 2 sin square theta into sine alpha upon cos alpha. This you will get. Okay, one more thing is there. If we need it, so we can just solve further also, otherwise this is sufficient. Okay, this is the, you can say, the equation of particular range for this projectile motion, okay, which is in the inclined plane. So the importance of this projectile motion is that this is a special case in which the body is moving in an inclined plane. So there we have to use the resolving component of gravitational acceleration. This is only important, rest thing will be remain same as we have studied. Okay, in a normal projectile motion, have you seen that horizontal component remains same, but this particular case there must be some particular retardation in the horizontal direction also. That's why I am using the normal equation. In a place of normal equation, I am using the motion equation in which the acceleration term is coming. So this was our general description of projectile motion in inclined plane. I hope that this video is helpful for you. So stay tuned to our channel and just like our video. Thank you.